Good morning, everyone. Hope you are doing well. Till now, we have studied that matter is made up of tiny particles called atoms, and one molecule of a gas at STP occupies 22.4 liter volume. Now, the next immediate interest is to determine the masses of atoms. So, let's begin with the concept of relative mass. Which of these heaps has higher mass? Yes, you have guessed it right. It's A. Here, we have not actually measured the mass, but we assumed that all the balls have equal masses. So, the heap A in which the number of balls is more will have more mass. Now let's solve this. We have taken two different pulses in two balls. Which of these balls has higher mass? Can we guess? Maybe not. It's because we cannot count the number of seeds of the pulses, and the pulses are not same, they are different. Now coming back to matter. Can we weigh an atom? Can we count the number of atoms present in a given amount of matter? Certainly not. Then how can we calculate the mass of an atom? This problem has been finally solved by Avogadro's hypothesis, which states that equal volumes of different gases contain equal number of molecules under similar condition of temperature and pressure. Let us understand with the help of an example. We have taken two cylinders of equal volumes. We have filled these cylinders with two different gases 1 and 2. The volume of first gas is V ml. Weight of gas W1. Mass of one atom M1. And the number of molecules occupying this volume V is equal to N1. Similarly, the volume for gas 2 remains same. Its weight is W2. The mass of its one atom is M2, and let the number of molecules be N2. Now, let us take the ratio of their weights. So, W1 divided by W2 is equal to N1 M1 divided by N2 M2. Now, according to Avogadro's hypothesis, since these gases occupy same volume V ml under same condition of temperature and pressure, so their number of molecules should be same. Hence, N1 is equal to N2. So, we get W1 upon W2 is equal to M1 upon M2, which means the ratio of their weights is equal to the ratio of the masses of their single molecules. From here, we can define atomic mass. The atomic mass of an element is the number of times an atom of that element is heavier than an atom of carbon 12 taken as 12. In chemistry, we take carbon 12 as the reference atom. The atomic mass can also be defined in other words as the atomic mass of an element is the average relative mass of its atoms as compared with an atom of carbon 12 taken as 12. gram atomic mass. The atomic mass of an element expressed in grams is called gram atomic mass. Now, since we know that the smallest particle of a matter which can exist independently is molecule. So, now we will define molecular mass. The molecular mass of a substance is the average relative mass of its molecules as compared with an atom of carbon 12 isotope taken as 12. How can we calculate the molecular mass? So, we can calculate the molecular mass by adding the atomic masses of all the atoms present in it. For example, we can calculate the molecular mass of NaCl by adding the atomic mass of sodium and the atomic mass of chlorine, which is equal to 23 plus 35.5, and it comes out to be 58.5 U. Here U is unified mass. Now atomic mass are expressed in C12 scale, taking the mass of this isotope as exactly 12. Let's take one more example. Molecular mass of NaOH is equal to atomic mass of sodium plus atomic mass of oxygen plus atomic mass of hydrogen, which is equal to 23 plus 16 plus 1, and it comes out to be 40 U. The molecular mass of an element expressed in grams is called gram molecular mass. Now, we can find the exact number of atoms or molecules in a given amount of substance by using the mole concept. It is found that 1 gram of any element contains equal number of atoms, and 1 gram molecule of any element contains equal number of molecules. Experimentally, this number is found to be 6.022 into 10 to power 23. It is called Avogadro number or Avogadro constant. So, we have Avogadro number, which is represented by Na equal to 6.022 into 10 to power 23. This value is referred to as 1 mole. So, 1 mole is equal to 6.022 into 10 to power 23 particles. This is similar to the concept of dozen. 1 dozen banana is equal to 12 bananas. 1 dozen balls is equal to 12 balls. 1 dozen pencils is equal to 12 pencils. So, we can say that dozen refers to a number. Similarly, 1 mole of sand particles is equal to 6.022 into 23 sand particles. 1 mole of grapes is equal to 6.022 into 10 to power 23 grapes. 1 mole of atoms is equal to 6.022 into 10 to power 23 atoms, and 1 mole of molecules is equal to 6.022 into 10 to power 23 molecules. Next, we have some term related to the mole. First is molar mass. The mass of 1 mole of any substance is referred to as molar mass. If it is a gas, then the volume occupied by 1 mole of a gas at STP is equal to molar volume, and this volume is found to be 22.4 liters. So now we have 1 mole of atoms is equal to 6.022 into 10 to power 23 atoms, or gram atomic mass. Similarly, 1 mole of molecules is equal to gram molecular mass, or 6.022 into 10 to power 23 molecules. And if it is a gas, then 1 mole of molecules is equal to 22.4 liter at STP. So that's all for today. In our next session, we will study about the unit system and measurements. Till then, stay home, stay safe. Thank you.